Acho que o vídeo ele não vai pôr no. Aqui tá saindo limpo som, hein?
Só um minutinho que tá saindo um som aqui na transmissão, peraí. Você ouve?
Não tô ouvindo também não.
Tá sem som.
Deixa eu tentar aqui de novo.
Uhum.
Ele não botou um vídeo no PPT.
Não sei como é que ele montou o BPT.
Isso que eu tenho confirmado pela hora.
Lá no Drive não vem esse vídeo separado, não?
Navegador de web. Esse que é o problema. Porque ali, alguma navegador de web. Não pode.
Você tá, a sua apresentação tá num navegador de web, não é o PowerPoint, né?
Eu salvei no PowerPoint.
E
Energia, a Nuclep, Nuclebras Equipamentos Pesados, é a maior caldeiraria pesada do Brasil. Somos uma empresa do ramo de energia pela própria natureza, fundados para atender, fortalecer e consolidar o programa nuclear brasileiro. E somos a única empresa brasileira capacitada à fabricação e manutenção dos equipamentos nucleares mais importantes do país. Desde 1980 já fabricamos para a eletronuclear os geradores de vapor substitutos para a usina de Angra 1 e os condensadores, acumuladores e racks supercompactos para a usina de Angra 2. Hoje, a nossa missão e foco é atender às instalações dos equipamentos da usina de Angra 3, que aqui estão. Com precisão e eficiência, fabricamos os seus condensadores, fundamentais para o resfriamento da água no circuito em operação da usina nuclear. 8 acumuladores, responsáveis pelo resfriamento em casos de eventos emergenciais. E o seu pressurizador, componente que mantém a água do circuito primário em estado líquido. Aqui estão também prontos à instalação a estrutura central do núcleo do reator de Angra 3, o vaso de pressão do reator e seu tampo de fechamento, o estator do gerador elétrico da usina, a turbina de alta pressão, seu rotor e geradores de vapor. A posição geográfica da Nuclep não é aleatória. Estamos estrategicamente localizados para atender com prioridade as necessidades da Central Nuclear Almirante Álvaro Alberto. Nosso terminal portuário privativo visa o pronto escoamento dos equipamentos para a eletronuclear e a proximidade das usinas, a manutenção e prestação de serviços essenciais. Devido à nossa versatilidade, atuamos em segmentos e projetos complexos, que requerem mão de obra específica e qualificada. Com isso, possuímos uma infraestrutura diferenciada com capacidade para absorver projetos únicos.
Sou Nuclep e trabalho pelo Brasil.
Eu sou Nuclep, eu trabalho pelo Brasil.
Eu sou Nuclep e trabalho pelo Brasil.
Tractebel is leading the way in the deployment of a new generation of reactors, the Small Modular Reactors or SMRs. SMRs are smaller, simpler and standardized modular reactors. Their components can be built in factories and shipped to site locations by truck or rail, making them quicker and far less expensive to build than traditional ones, which facilitates investment for private actors. They also incorporate the most advanced features of the nuclear technology. They can provide carbon-neutral and reliable energy to complement intermittent renewables when the sun does not shine or the wind does not blow, to power or deliver process heat to heavy industries and cities, and to produce low-carbon hydrogen to fuel planes or boats. Our nuclear know-how and innovation enable us to support nuclear and industrial players to successfully deliver SMR projects.
Tractable offers the healthcare sector a unique combination of infrastructure, nuclear, and radioprotection skills.
A one-stop-shop approach to design facilities hosting nuclear medicine equipment and radiotherapy while putting sustainability at the center of every decision.
Our multidisciplinary approach is increasingly valuable as the use of nuclear medicine is growing by 5% per year, and 1 in 2 people will benefit from it during their lifetime.
One example of a project combining Tractable's infrastructure and nuclear expertise is the CHE Montlégat, the new 100,000 square meter hospital in Liège, Belgium.
Montlégat includes a nuclear medicine department that requires specific skills to complete, especially in the field of heating, ventilation, and air conditioning.
The client requested a sustainable building, so we designed it around energy and water saving. We incorporated several passive design features like optimal positioning of the building and the orientation of its windows to require fewer heating and cooling systems.
Our combination of nuclear and infrastructure expertise makes Tractable the ideal partner because we can accompany healthcare stakeholders throughout the entire project from idea and basic design to project management and civil engineering.
We cover every phase of the project through our broad range of competences like structural, mechanical, electrical design, 3D modeling, fire safety, radio protection, rat waste management, nuclear safety and decommissioning.
Tractable combines infrastructure and nuclear expertise to develop sustainable healthcare facilities.
For cutting-edge research, diagnosis and treatment for the well-being of people around the world.
Juntos, construímos uma trajetória de grandes realizações, aprendizados e renovação, o que nos fez ter a certeza de quem realmente somos. Esta é a nossa marca. Ela reflete grandes mudanças e uma história de 75 anos. Nosso símbolo, um quadrado formado por 4 semicírculos, é inspirado na união da engenharia com a confiança nas pessoas. As formas revelam integração, enquanto a combinação do azul com o verde representa o equilíbrio entre a nossa capacidade técnica e a sustentabilidade. O conjunto expressa dinamismo, visão panorâmica e a renovação do nosso olhar para o futuro. Somos agentes de uma profunda transformação. Acreditamos na capacidade ilimitada das pessoas e servimos a uma sociedade em constante evolução. Com competência técnica e desenvolvimento sustentável, trabalhamos para ser a cada dia mais competitivos e inovadores, atuando de forma ética, íntegra e transparente. São muitos os desafios, mas um objetivo nos une: construir confiança para um futuro melhor. OEC. Se é concreto, é de verdade.
Boa tarde a todos. Meu nome é Carlos Leipner.
Good afternoon.
Eu sirvo como
Carlos Leitner. I'm the Vice President of ABDAM's Board of Directors, and I'm also part of an NGO that focuses on decarbonization of energetic matrix in Brazil. And it's with a huge pleasure that I'm here to welcome you all once again to nt2e. Another session for, and our theme today is small modular reactors. And in the next 90 minutes, we're going to be talking about the deployment of SMRs, licensing, and project development. And I would like to welcome our speakers that will be part of our table. And we also have a speaker online. Please, Dr. Jefferson Borges, please. Admiral Ruivo from the Brazil Marine. And also online from the United States, Marcio Paes Barreto, that I'm going to present to you in a minute. So please. So I have a 30-year experience in the nuclear sector, and I've seen this global sector in moments of growth. And once again, in the past 5 to 7 years, we see this gap that we have an opportunity for nuclear growth globally, really, and also here in Brazil for the past 4 to 5 years. So it's very interesting, and obviously there's a big impulse that is about SMRs. So there's a huge demand for information and technological development, and also interest in that sort of technology for many reasons. We now see data from agencies. We have over 80 projects of SMRs being developed around the world. I think we've mentioned that before. And it's interesting to see that SMRs are not homogeneous. We have different types of technology, different sizes, and different applications, and that's very interesting. As a nuclear engineer, I get very excited about this, but at the same time, we have these problems and issues that we have to understand how they are applied when we're talking about regulation. How can we develop these projects and its different applications without talking about electric generation, for example? So we have an interesting context, and we're going to talk a little bit more about that this afternoon. And now regarding licensing and location, I think it's interesting to see that the methods for location and site choosing have been improved by the necessity to incorporate these characteristics that are very interesting with SMRs. And something that we mention a lot is these emergency locations that, and we have these places that are big in area, but these emergency areas, they cover a larger region. And now we see that SMRs, because of their size that is obviously smaller, so they're so much smaller than regular ones, we see them even smaller than the site that are necessary to have that. So we can see that they can be placed closer to the population and closer to demand centers. So we have to think, how do we incorporate these features in a regulatory process? So anyway, we have a methodology for location, for site location, and we have been through many updates of our evaluation, and the criteria that we have launched in 2022, they incorporate these SMR's characteristics, but also the more exotic ones that are not water-based or boiling water, but they incorporate high temperature gas or salts and fast reactors. So we have these things that are being incorporated in the methodology of how to choose a location, and regulatory regulations are also incorporating these characteristics. So in Brazil, that's very interesting. We have a high range of opportunities, and I'm very happy to have this forum here, and with so many discussions, and we're exactly trying to understand how to incorporate SMR with our strategic plans in Brazil and for different applications that go beyond electricity generation. So I'm very happy with the table we have here today. We're starting with Marcio from United States. He is Brazilian, but he's been in the United States for a long time now. He is the Director of Industrial Development of Wyoming State Secretary for Energy. He has a formation of industrial engineering here in Rio de Janeiro. So it's really a shame that we don't have him here with us, but it's a big pleasure to have him online. So Marcio, you have the floor. Thank you so much, Carlos. Can you hear me well? Yes. Perfect. Again, my name is Marcio Paz Barreto, and I work for the Wyoming Mines and Energy Secretary. I'm going to make a very brief presentation with a few slides, and then I will yield the floor back to you, Carlos. Can you see my slides, Carlos? Yep. Yeah. Okay. Perfect. So you've mentioned that I am Brazilian. I believe that I am a product of Rio de Janeiro. I have lived there for a long time. I studied in the military school. My biggest references and influencers for the energy sector, I had professors like George and Luis Felipe Bassani. I have worked for welding sector companies in Rio de Janeiro, and that was a while ago. And so keeping a family tradition that they migrated from Portugal to Brazil, and so I ended up moving here to the US. I work now at the Wyoming state. It's about a 15-hour flight from Rio. I'm so sorry I couldn't be there with you. I had a big meeting here, and I couldn't make it to Rio. So the state of Wyoming is very wealthy with its nature. So we have a few pictures here that are references to our geography. And below the soil, we also have so many wealth resources. And just to give you an idea, a few quick facts. We produce energy in the Wyoming state. We produce 13 times more energy than we consume. So it's really, we're only after Texas energy production wise. So we're the state that we're the top coal producing state since 1986. We are the 8th state in terms of production of oil, and in terms of emerging energy resources like wind, we were also able to implement a few of those units here in a state. If you weigh the participation of our secretary in the state, we're only after the state of Louisiana. So at the same time that we're exploiting these under the soil riches, we're also exploiting over the soil richness. So we have over 150 miles of roads that cross the state. So if you think about it, is a very important state when we're talking about energy, and it's going through its energetic transition in the best way we can, preserving the industries we already have and helping new ones that are coming without losing the prosperity that the energy sector brings to the sector. A couple of other facts, just so you understand. The population of our state is only 580,000 people. That's really equivalent to the south zone of Rio de Janeiro. But the state is a little bit larger than São Paulo. So you see that we have a big geographical dispersion. And all of that happens because our people that we're so amazing, because we can preserve natural resources. I'm gonna play a quick video so you can understand the culture that we have in our state, because you can see that the people that are using these natural resources, how important they are.
They were restless spirits, dreamers, outlaws. They came from the unspoiled, the freedom from judgment. They came with new ideas and learned from ancient lore. In the West, they didn't just find a place, they discovered the truth, that the path of least resistance must be resisted. The truth lies west. It's time to discover yours.
Então ele mostra pouquinho que as pessoas que vieram para cá vieram com esse espírito de explorador.
The people that came here, they came with this brave spirit. And so, I don't know if you were able to hear the video, but so with that background, in June 2021, one of the companies that produces advanced reactors, TerraPower, they announced that they would have their project in the Wyoming Stadium. Back then, they thought that they had around 4 communities in Wyoming that would be able to hold that project. And then after a selection and the involvement with the government, they chose the city of Camera in Wyoming. So you might imagine that announcement like that to our governor and to our senators and the leaders of this company, that motivated and accelerated the development of nuclear energy in the state of Wyoming. We had already in the 60s tested a reactor that produced 1.3 megawatts of electricity and a little bit more of heat in a remote station here. So now that we're entering this second demonstration and within a uranium industry in our state, so that has accelerated things quite quickly. And the department that I work for, we have the goal to inform our public and the people that the decision makers and the lawmakers about the opportunities that we have in these new technologies to include nuclear energy. And we also have a mandate to coordinate the efforts of the states, everything that we do for the development of energy. And lastly, on behalf of the people of Wyoming, to coordinate the developments that will bring benefits and prosperity to the state. And like I described to you, we have so many natural riches. So one of the works that we do is to talk about the density of that energy. So you might imagine that a few emerging technologies like eolic and solar, they will gain a lot of attention when we're talking about nuclear energy as well. So that's important to inform these lawmakers, these decision makers. And throughout that process, our leaders, our state leaders, they started talking, well, we have to develop a lot more than just a small reactor. How do we develop a roadmap? So when we started developing a roadmap, this was exactly the road that we saw in front of us, very foggy. So how do you develop a roadmap that maximizes the opportunities for nuclear opportunities? So we decided to abandon that idea of a roadmap and decided to create a framework that helps these companies that are working in the sector, in the governments, local governments and state governments, to understand what road they were traveling in. So you might imagine that one opportunity for our state that is electricity generation using advanced technologies, and the other opportunity is to develop a supply chain of uranium until the materials and final byproducts that support nuclear industry. And the last one, but not the least important, is how do we develop applications of heat and electricity that come from these advanced reactors. More importantly than what is in this development framework is how do we develop this? Because in a conservative state as in Wyoming, we ask what is the role of the federal government and state government to invest in that industry that can maintain prosperity and even increase sustainability of our energy system. Well, we believe that we need industry engagement. We have to find what are the public services and the inputs that come from both state government and federal government that can help these companies to be productive and efficient in that area. But there's another important element that is to involve that local ecosystem of small and medium entrepreneurs and companies that can support that development. One of the questions that I think we're going to discuss here is how do you engage in these communities? And that starts with the private local sector. Why? Well, why is this important to have them engaged, of the small and medium companies? I like Henry Ford's sayings here because, first of all, they're very proactive. And then we have the opportunity around these emerging industries. And second of all, they don't think they need a complete roadmap that foresees any sort of disruption or any accidents. There's a difference in the timeline and the approach in the project. They have that vision of reiterating and heading towards the solutions. And just to make my final points here, the question is, how do you leverage these different industries? One with the electricity generation, the other one the supply chain, and lastly, the industrial application of these reactors. And really just to finish up here before yielding back to Carlos, I think it's very important to define the different types of reactors in size. They will play different roles in these pillars. For example, advanced reactors that have 1 gigawatt size, they play a very important role in a grid, for example. Smaller reactors, smaller advanced reactors, they might play an important role in the macro grids. And the industrial application, maybe we will have macro reactors that are very small reactors, and that differentiation, that that we have different types of reactors, but also different size of reactors is also important when we're talking about the deployment of the vision. Carlos, back to you. Thank you very much, Marcio, for talking about your project. We're observing that development in Wyoming with, we're paying very much attention, is a project that for many reasons, but not only because of technology, it's because we're talking about the Industry 4.0 is also one of the first ones in the United States, but also the applications that it is to replace these coal industries with nuclear generating energy. So very interesting in this energetic transition. So we will continue to pay close attention to you. Thank you very much, Marcio. Okay, so we will now, I'd like to invite Dr. Jefferson Borges to say a few words about his perspectives of KINENG. He is the General Coordinator of KINENG in the fuel and small generators. Welcome to our panel. First of all, I'd like to thank Abdem for the invitation. It's always great to bring a little bit of information to the public. And I would like to ask that this will not be exclusive to this opportunity. We have our doors open to whoever wants to talk a little bit more about this. I will clarify a little bit to you of how the licensing process for small modulators works. And something that Marcio mentioned that is fundamental for every project that we start licensing or even start talking about is the involvement and engagement of society, of that local population. That's the first thing that has to be done, and it's important to be considered. Okay, so let me just briefly talk about KINENG and our mission, our structure, and the licensing process, and really the revision of our norms and how it has changed in the past, and we are now even considering receiving a few new material about smaller reactors, and we're going to talk a little bit more about how the agency is inserted in that context. And briefly, the experience that we have with small modulators reactors. We have experience with that in Sorocaba. So the advancements of REB, but also the marine project is also advancing. And I'd like to make a few technical considerations that we have regarding that theme. So our mission is to ensure that the public is safe, our workers are safe, and the environment is safe when we're talking about nuclear facilities. KINENG has two boards of directors. We have one for radio protection and safety that takes care of auditing these radioactive and nuclear facilities, and the other one, that's a board of directors that works for research, that is responsible, for example, for that second goal that we have, that's to develop and make available nuclear-related technologies and improve the welfare of the population so that they can benefit from nuclear energy. So just to give you an idea how KINENG is spread all through our national territory. In Rio de Janeiro, we have 3 units. We have our matrix, and that supports our licensing units, and the Institute of Nuclear Research in São Paulo. We also have the research in Belo Horizonte. We have also another center for research in Recife. We have a unit in Goiás. We also have the Center for Radioactive Activities. And we also have a district that's sort of a branch of KINENG to audit these units. Also in Resende, we have an advanced branch for that sort of in Bahia, we have a unit that is also responsible for auditing mining, that is responsible. And in the future, we will also have an office in the mining that is starting in Santa Quitéria. We also have a unit in Fortaleza for a few inspections that might be necessary in the northeast of Brazil. We also have a laboratory in Caldas Novas. So just to give you an idea, this is an organization chart. We are now fiscalizing units for the Ministry of Energy, Mines and Energy. We are also responsible for a few activities of the marine, a few activities in CTSB, and a few marine locations. And our board of directors, we have for radio protection and safety, we have two main coordinators that we have, and our general coordination about fuels. And so we have two different coordinators, and that CODRI that's responsible for research and also for storage, for fuel storage. So we have three different divisions for the engineering, and we also have another coordination that's responsible for attending international affairs. So this is just a few numbers, so you can, nowadays we have over 1,500 workers. So 32% of them have specialization, 30% have PhD, 18% have a master's degree. And within those 1,500 employees, 223 of them are part of the labor force. They are responsible for our reactors. So that's about, so we have not so many people responsible for so many facilities. So under our responsibility, we have 2 nuclear power plants in operation, Angra 1 and 2, 1 in construction, Angra 3, 1 test reactor in licensing, 1 nuclear spent fuel dry storage, and I'd like to say that this was licensed in a record time, in 6 months, and also and it's important to say that that was post-pandemic. 1 waste management center in Angra, also CGNY. We have over 3,000 radioactive facilities and over 30 mining and milling facilities that are associated to mining that are also audited by an agency that is also under our umbrella, and other installations that support Kinning.
We have the licensing of the operators. It's like a pilot of an aircraft. They have hard training, then they are evaluated. We have a process of certification for the supervisors, the revision of documents of the International Agency of Atomic Energy, international agreements, mainly for safeguard, and also the definition and control of the mineral reserves from Brazil. Please, next slide. This is to show the numbers regarding the activities that are licensed by the coordination of medicine and in the previous units that I mentioned. Here are some interesting pictures. The first one is linked to SME, the complex of specialized maintenance, LabGeni, there, and the first picture below, and also RMB. Here you can see URA, a facility of decommissioning. We have a special attention since the first day that we start working there. And the plants of Angra. The last pictures just to show the last facility. And the units that we have a dry storage. So we have Angra with 37 elements, the other one with 32 elements that are stored with the natural circulation. That is, it's a passive system, so with the difference of temperature, we can use it. Well, what we have to monitor here, it's a set of standards and laws that are split into 5 groups. This is the group 1, that is about the nuclear reactors and some facilities with nuclear standard. All those standards are in our website. Here you can see the other groups. One for the nuclear facilities, the material control, the transportation, certification of people, the waste management, and decommissioning. Well, now we're going to talk about the main subject, that is the standards that are being developed. So we start some time ago. This is under revision, that is the selection of the sites. So in this standard of the selection of sites, we are approaching some aspects linked to the SPORI Act. An example, the gradual application and the process of licensing. We are removing from this first part, we will see that the process of licensing, the approval of the local. Sorry, we are not receiving the audio to proceed with the translation. Cadê o... Você está escutando? Well, we have a 1.04 that describes the process of licensing as a whole. We will see more details shortly. The point 14 that establishes what should be noticed for the regulator and which time. So today we have some events that must be notified in 1 hour or up to 4 hours, and each event has a detailed report, and they suffer security analysis. They will verify the impact and the safety, the root cause, the corrective actions that are required, and others. 1.21, the maintenance. So based on the experience that we have for long term, we are including different requirements inside this standard. This initially had a reference as a guide in the agency and was released after the rule of maintenance. So we are now incorporating those details and the experiences that we had over time. We have some emergency plans. We have a new standard about this with different processes to be followed. So we are also with a new standard regarding the safety and security. So now we have a pathway to develop those products. So this commission of the facilities, there is a new standard, and we didn't have for the nuclear facilities, and now we are creating this. And finally, one for the transportation of fuel. Wow. Just to support our process, and this will help a lot regarding the small reactors, we have a cooperation with Argentina ongoing, so we are talking with them so that they can send some technicians to follow up on the construction and the commissioning on the ones that are under construction. Australia, we had in December the first meeting so that we can narrow the spaces for technical cooperation, and in this context we insert also the small reactors regarding OPAL and VAB that they have over there. The European community, we have a technical cooperation for long term with more than 12 projects approved, and we ended with a success. And inside this scope we have the need of training, so we are sending, for example, 2 engineers to Estonia to participate in a workshop regarding reactors, the licensing of small reactors. With RMC, we had a conference regarding regulation in last March, and PNC, that is the institution that regulates in the US, so they ask a bilateral meeting so that we can discuss some spaces for technical cooperation. And one of the spaces that we focused on was the licensing of small reactors. And finally, the International Agency for Atomic Energy, we had a meeting about this, and also we have two parts, one for the operators and one for the regulators. And one of our engineers is part of this, let's say, the committee, Gutierrez. Here we have a vision of how the process of licensing is working. So everything starts with the submission of a report. We have a security assessment, and then having this approved, we submit a preliminary report. We will see more details further, and we can, after the security evaluation that is approved, we can have an authorization for the construction. During the construction, we have different surveillance and monitoring, so to ensure that they are built according to this report of security analysis. After the construction, we have a new report that is called the final report of security analysis. So we can see what were the modifications in the project or in the construction that were necessary over the construction. So we have this commissioning A, B, C, and D, and with the approval of this report of operation, by the approval of this final report of security, we can have the licensing for the first operations, so the physical text, to verify all the features of the reactors, the heat, and other parameters. And based on this, we start the operation, the permanent operation. And the plant of Angra 1 was licensed to operate for 40 years, following the development of technology. The operator submitted to SENEI the inspection to have 30 years. So we have been working with this, remembering that Angra 1 is ending the authorization for operation in December of 24. So this is the time that we have. We were analyzing this over time. So we need to evaluate and grant or not the extension of the term. And we have a news regarding the periodic assessment of security that didn't exist, and now we have, and this is very important. That is, in each 10 years, it's necessary to have a evaluation regarding the security margins. We have the document of the agency that establishes 14 factors of security, and they are analyzed and verified regarding the security, safety and security, and then this commissioning. The main challenges that we have been seeing in the process of licensing, first of all, is the human resources. When I was talking in the beginning, when today we have 27 engineers to care about the nuclear plants and the reactors of research, these 27 in the past were 60 with one plant under operation. So this is a huge challenge to recover the human resources and also to provide them technical skills, because they need a time for training and extensive training. So the update of the standards, this we are doing. The existence of a reference plant, this is something that gives a lot of comfort for us, and this is the reason that we did the licenses of OS in record time, because we had a facility in the US that was already certified. So what we did basically was to verify the adaptations that were required and the requirements for emergency plan. We received news that the methodology of NEU's case for the producers of the small reactors for emergency plans were accepted by RNC, but we didn't have details so far. And the RNC so far doesn't have a standard. There is a final draft for emergency start standard in the small reactors, but so far we don't have this ended. As Lieutenant said in the beginning, and was also stated by Márcio, we have different reactors. So it is important to say that, first of all, different types of reactors, we are more comfortable. Okay, this doesn't mean that we will not analyze other types of reactors. It's important to mention that SENEI is not choosing the type of reactor. SENEI receives from an operator requests for licensing for a certain reactor, and depending on the type of reactor, we will demand more or less time, because we will verify the need of a more deep approach for other types of reactors. And the main thing is the communication with the society. Based on my experience, not with the reactors of Angra that are accepted by the local community, but we have some research that demonstrates this. But other facilities, we verify the community that is feeling this getting close from the operator. So it's important in the process of release and in the process of to get close to the facility and also with the community. So here we have some examples. If you are interested in, there are different web sites of NMC that states about the small reactor subject. So in these websites, this one, regulations, guidelines, and communications for new reactors, this establishes the rule of the game that is used today for the licensing of nuclear plants. In others, we are talking about the emergency plan and other subjects regarding this area. Here, what are the guidelines that are used today for licensing? And we see there, so Norwegian 0800, that is the same guide that is used for the big size plants. Here you can see the drafts that I mentioned that are available, and they talk about the standard of maintenance that is in the final phase of assessment. Here is an important slide just to give an idea what is evaluated in the process of licensing of a nuclear plant. So you have a description of the structures, you have the reactor, the description of the reactor, the primary system, the security system, the systems and controls, the electrical systems, the auxiliary system, the steam conversion, the radiological protection, the tests of commissioning, the criteria of acceptance, the analysis of the accidents, because with this analysis we will have the impact in the emergency plan. So when we hear from the research coordinator that the planning area of emergency is around the site, is because the accidents that are inside were considered and the consequences and impacts are inside this area. The quality assurance, and this is also an important point, because if we need to deal with a standard of SENEM or in a US norm, when we are talking about supply chain or to involve the local industry, it's important that the local industry that is linked to the reactor construction is important to be aware of the importance of the quality of the material, the raw material or the product that they will provide for the small reactors, because we don't have any failure in the operational events because a certain equipment or component failed. So the quality assurance allows, for example, the trackability of the equipment that may fail, the material that is being used, just to minimize this type of situation. A part regarding the assessment of security and safety and severe accidents, a part of for mitigation and evaluation of the events beyond the events, and the 21st chapter is regarding the reactors of Pontes, regarding different models, for example, the smart reactors in the same site. Here we have some examples of the pages of the International Agency of Atomic Energy that also provides different information. One more, please. Here it's a definition of the small reactors that is less than 300 megawatts. I think that you heard about this a lot. Here the agency has a document. It's a page that is called ARIS, where it is presented in each 2 years a document that is important document showing the development of the small reactors over the world, where we can find more than 80 types of or producers on projects of small reactors that we have in the world, and they are split into those 6 items: the water cooled, and with the marine water cooled, the high temperature gas, the salt, and so we have 25 types of reactors that are cooled by water, the small reactors, and so on. Here, this area is a page. We have different information sometimes of reactors. We cannot have all of them here. And there is a detailed information for each one here inside this document, and they present some tables summarizing these types. So we have 20 here, the SMN 306 is here, and different types of small reactors are here. More small reactors, please. Here, another part of the platform of SMR. One more, please. Documents that we release to support the state members in the process of licensing. We have 4 here. TechDoc, it's a document of the agency that try to share the operational experience. So recent documents from 2020 and 21. So we have, for example, some lessons learned in the reactors of small size, some considerations for the impact in the environment. We have the roadmap, besides the other documents of the ARISH, the benefits of the challenges for the rapid reactors in the small size. This is the recent document from 2022. In each 2 years, as I mentioned, we have some bilateral documents, so the agency release a document that is summarizing the development of this technology. The last slide, I talked a lot. So the rules of the norms that are applied, that are being used, and we are considering the application that is gradual. So first we have SMR that is not in operation, and it's not going to start in the coming years. I was taking a look in a WNN, work nuclear use, and the scale went to 2030, the first operation, perhaps the MRX in operation 2028, 29. So we have time to develop this. It is necessary a plan of reference to facilitate the licensing and agreed approach that we are thinking to use, but we need human resources, and we use extensively for the operations. Just to add, and I would like to say that we have an open mind when we are licensing a facility, mainly in a new facility. RMB is there as an example, and LabJamie from the Navy also is here. We have as a norm to grant some partial licenses for construction, and LabJite is in the 5th license. So we have LP60 that was granted last month, specific for non-nuclear building, a building of control, and we are authorizing the assemble. Basically, is regarding the cold water and the demineral water. So RMB, we are start talking about this so that we can understand if we can go in this way also. And why this is lasting a little bit? Because there is a process of construction in a report of new things. So there are handled different technical discussions with the people that are willing the licensing. So this can evolve in a more smooth way. Thank you. Thank you, Jefferson. Really, it's a huge challenge for the regulator, for the National Commission in Brazil, not only by the different technologies as you approach it, but the different applications and the part of human resources, as you mentioned. This is an issue not only in Brazil, but we see this in the global sector, and this is a bottleneck. But it's important to see this collaboration and cooperation. This is very important to leverage the next steps. So congratulations. So now we have here Admiral Rui that is here. He's the director of the Navy Agency of Nuclear Security in the Navy. He has a long experience in the nuclear sector with different roles, including being a technical director of heating of uranium and other activities. So be very welcome, and the floor is yours, please. So, ladies and gentlemen, good afternoon. I would like, on behalf of Mr. Carlos Morda, the moderator of this panel, to greet all the authorities that are here, the speakers, and you all that are here, and this is very good for this event. I would like to thank also the president of AGNAN, Mr. Celso Cunha, by the invitation that was sent out to the Naval Agency so that we could have the opportunity to once more to be present in the nt2e, as we have been highlighting. This is an expressive event in the area of business and technology in the nuclear sector in Brazil. So the event is being consolidated with this new occurrences. So in this presentation, in the subject of the implementation of SMR, the licensing, the localization, and the development of projects, I will focus my presentation specifically in the safety of SMR that are on board. I would like also to anticipate the thanks to Jefferson that with his presentation anticipated some slides that are also in my presentation. So as I'm the third one, I'm repeating in a way the previous slides, but I will try to be brief so that you can have more enthusiasm. So I intend to follow this agenda to meet the proposal of this lecture. I will approach the techniques regarding the concepts of SMR and also the matters regarding the use of this technology in the naval means. Also, I will talk about the commissioning, the licensing of these means regarding the nuclear safety and how this subject is being considered in Brazil currently. And also, I will present a proposal of a forum of international debate that will join some stakeholders, considering the possibility of jobs that we see in the SMR. It's increasing potential in the naval means, and I will explain why. And the challenges that are linked to this potential of jobs. So the challenges need to be overcome regarding the harmonization. There is the regulation framework that has to do with the application in the nuclear area and also regarding the naval licensing. So I will repeat the slide that was previously showed, but I will talk briefly regarding the concept of SMRs, remembering there are reactors classified as advanced reactors with different uses. However, in the majority of the cases, they are related to the production of electrical energy with the power of up to 300 megawatts electrical that can be grouped by modules meeting the demand of each operator. And I would like to highlight 2 points that I consider important in the context of this presentation. The first is the range of potence. The naval reactors, they are in this range of potence in less than 300 megawatts. They start in the range of a few megawatts up to 250 megawatts. And so they fit in this context. What we have regarding news that I would like to highlight is the reactor and the module conception and the production and licensing, and this can leverage the naval industry. And some particularities and advantages of the SMR as a whole. I can state here as the main advantages the potential that they have to reduce the global warming. Once it is using some technologies with a low emission of carbon, they can be produced and assembled in one block and be transported to the place of use. They can have passive safety systems, simplifying some operational procedures and less human intervention. The assembly can be simple, considering that this block is integrated and assembled in the specialized producer, and then it is transported to the site of the installation. It can be on board or not, and this can meet the requirements from different operators. And in the end, I will leave 2 questions just to provoke the industry regarding the potential gains regarding cost and terms of producing, and I think this is a differential that can be used by the naval sector, and this requires a proof up to which point the kilowatt per hour produced in the SMR can be competitive from the point of view of the cost of assemble and operation. Well, this slide is saying about the world interest regarding this subject. Here it's an information from the International Agency of Atomic Energy. In a very summarized way, this is showing that the information in the interest for this type of technology is spread in different states, as it was mentioned before by Life Menor. More than 80 projects today are being developed by 18 state members. This shows global interest. In this slide, we highlight the importance of IRIS, this database from the International Agency that shows different information regarding advanced reactors. And there, if you click there in this window, SMR, it will appear around 50 reactors that shows a basis, a database that is very important for those that want to know the types of technology that are being used in this reactor, the types of cooling, and what these reactors, in which phase they are right now. The research that we did shows that among these types, the SMRs under development, the ones that are water-cooled, they are a very important in terms of numbers, representing a success in this type of cooling in reactors of big size today used for the production of energy. Besides the conventional use, we notice in the database that there are some projects destined for the production of hydrogen and water, as the Professor Cotter will talk today in his panel. The warming, the heating in the industries, the extraction of oil and gas. So,
well, now I'll start talking about onboard nuclear reactors, and I go back in 1950, and there's a timeline here with a few projects of submarines and ships that were highlighted in the employment of reactors. These small reactors, they have been delivered in a nuclear proportion for years now, for about 70 years, both for military on board and civil boardings. These naval ships are very well known to employ this sort of propulsion, even though back then these projects were not organized with a modular use. They were put together in a different way, so we have a very different type of assembling. It took a lot longer than the ones that we have with the modulators. Nowadays, there's a big interest for onboard nuclear reactor production, and it's continuously growing. I feel that there's this new class of ice-breaking ships, and they use nuclear propulsion, and both of them are in operation, and we have 3 more under construction. Well, this slide shows you a little bit of the experience of the naval sector and the application of nuclear. It talks a little bit about Russia and United States, and they have approximately 12,500 reactors that are in operation. So that means that they have operated at sea for a long time, over 70 years of results that were obtained and consolidated for naval operations, in special for military naval use. So those that have will never stop using it, and those that don't have are very interested in acquiring. We also have Lloyd's Register that show that since the 1950s, over 700 reactors were used at sea, so it's a reasonable amount. And in 2021, about 160 ships used nuclear propulsion, and most of them were submarines. the use of this technology for commercial ships did not really have the same sort of acceptance as military use has, probably because of its high costs and that are associated to assembling and licensing difficulties, and also access to international ports. So, for example, a ship that was licensed by a state will not necessarily be able to operate with the same facility, the same in a different port in a different country. But I understand that SMRs have a huge potential to change that scenario. Here on this slide, we have a few pictures, and I'm going to talk a little bit about each one of them. So they have a potential to, we see a potential to become more attractive for the use in civil ships. Reactors may contribute to the reduction of CO2 emission once the sector of marine transportation presents relevant contributions to the emission of CO2 and the greenhouse effects. So a few shipping companies have been studying alternative footprints for, and nuclear power plants are valid alternatives. We have ports that already adopt the use of this technology, and these modules can be required, and they might be integrated by the constructing shipping. So, and that goes very well along with SMR's technologies, because we have this huge block being transferred to the shipping that are so an SMR that is ready for naval use, that is provided by a specialized company. They have the potential for the reduction of costs and time production that in relation to what was done in the past. This slide shows a few of the initiatives of the ones that are in under construction. So we have 8 water-cooled projects for onboard use. For example, we have projects under development in many countries. We highlight that in the first image on the upper part here. We have an SMR that's applied in the offshore. And I don't think that the image is very clear, but you can see that we have that part, an SMR that has the vase and all its components working there. And in the lower part, we have what's the concept of a shipping for energy production. On this slide, we have 2 different shippings. That on the left, we have a big barge in operation that does not use propulsion and has the goal of energy production, and it has a capacity for 70 megawatts. And on the right, we can see an equivalent concept, but in a higher scale, that can use 2 to 8 modules of 100 megawatts each, so they can reach up to 800 megawatts of energy generation. So we see a potential interest in growth in SMRs for civil shippings also. And I'd like to highlight that the use of SMRs for internal use had their origins because of onboard reactors. So an interesting part of what we see now were before used in shipping in military. And then just a little bit about regulation. We have the main objectives for the nuclear regulation are traditionally applied to large reactors, and we can also apply them to small reactors. So we have these nuclear safety laws that ensure minimal radiological exposure that would be below prescribed thresholds, mitigating their effects, and minimal probability of accidents, and in case they happen, mitigate their consequences. Regulatory framework follows the international agency principles that we have principles, criteria and requirements by an image that we see here. And we demand that to happen so we can have concessions for the issuance, amendment, and revocation of licenses. And if those are not complied with in the audits that we make, we can then revocate these licenses. They can ask this with their regulation agencies throughout all the life cycle of the construction process. Now, a little bit about the SMR regulation. We have been trying to simplify these licensing projects, and the International Agency of Atomic Energy has been coordinating with its member states, and we're trying to standardize the process of licensing so we can foster international commerce and also the operations involving SMRs in different countries. And in this context, we are looking for discussions of particularities, widening the cooperation between these regulatory agencies, and harmonize practices and regulatory procedures, and I'm going to talk a little bit more about that in the future, contributing to a better use of these SMRs. Now, what about NRC? Just very quickly, I'd just like to say that they have also been developing works in that area, and also the development of a specific area for water-cooled reactors up to 300 megawatts. We have requirements for physical safety. And a little bit about Brazil now. What is the Brazilian model and what are we working on? An example of what happens in other states that operate naval ships, Brazil has 2 regulatory agencies that work aligned independently but collaboratively. We have a cooperation deal with the National Institute for Nuclear Agency that we discuss a few aspects that can be useful for these organizations. So we have the Naval Authority, ANSN, that has the functions that are part of the Committee for Nuclear Energy, and the Secretary of Nuclear Usage that is used for basically naval subjects. And I was recently invited by the Marine Admiral that had an upgrade in that agency and transformed it into a secretary that responds directly to a Marine officer. And we have our Admiral Squadra Rocha to be the president of that agency. And it's important to highlight, and just a detail here, with this upgrade, the secretary will expand and acquire some new attributions. It's important to highlight that these internal facilities from the Marine, as mentioned before by Jefferson, we have the special operations in Itaguaí, and they are licensed by the national authorities. In case of occasional SMRs that are allowed to work to be placed in Brazil, we intend to keep the same regulatory models. So the ones that operate inland will also be regulated by the ones that will work on board. I don't know if I'm being confused here, but they will be regulated independently but collaboratively. So the base for that article is Law 14222 from 2021. I'm not going to read the whole text. I believe you can see here, and you will have the slides available to you in case you're interested in getting to know more details. I'd like to highlight that the Naval Secretary is the authority that receives the competencies from the Commandant to exercise is foreseen in the law. Now, a little bit more about the regulation, nuclear regulation in Brazil regarding naval licensing. How are we working here? So we consider that these nuclear plants, the naval safety is interdependent and must be approached integratively. We have a few aspects here, and more specifically, marine safety and naval surveillance. We use as a practice articles from the IMO and projects that are constructed in the Brazilian Marine that have transferred information from to the Brazilian Marine. We also have standards that were adopted in the nuclear industry, and not always we're able to use the same practices and the same procedures due to big differences in the facilities and the weight of these equipment. So naval safety here, that's represented by the normative archpost that was developed by the Brazilian Marine. We use international norms that are our initial references. Here on the right, we have this circle that has been received a nickname of a mandala. We have regulatory framework that we are applying for the licensing of a conventional submarine with nuclear propulsion made in Brazil. Well, now this is my last slide, and taking into account that we have already mentioned the initiatives for the development of an international group of laws that will apply to SMRs and the huge potential of employment of these civil shipping operations, we have to understand that the importance of these naval regulatory agencies like INMO and other certifying agencies that are internationally recognized by the naval sector. If we don't do that, and if we don't gather and have the cooperation of these organizations, we will not have what happens today, for example, what happens in civil aviation. So, for example, an airplane is able to depart and take in all types of airports, and they're only able to do that because there is collaboration between the agencies in that area. So we have to potentialize the use of small modular reactors, especially for the naval system. And we have to do that it's a very important task. With that, we would like to have a multilateral forum that is very much possibly to be regulated by the Atomic Energy Agency that gathers all of these stakeholders with the idea of having new facilitating rules for the construction and operation of civil, naval, and naval operations. Well, ladies and gentlemen, that's my presentation for today. Once again, I thank for the opportunity of being here in such a relevant and important event for the nuclear sector in Brazil. Have a good afternoon. Thank you very much for these data, and it's really an interesting sector. We end up focusing on land SMRs, but we cannot forget the onboard SMRs. It's a very dynamic sector, and it has many applications that are very interesting. So thank you very much. We're heading towards the end of our presentation. So maybe just a quick question to a few to our speakers, and starting with Comandante Ruivo. So how would this issue with the safeguards for nuclear material in the context of on-board ships? It's something that I consider in the we have to sign deals, comprehensive safeguard agreements with international agencies in a way that the agencies can account for and control the nuclear material that are employed in all of the facilities in the segment states of this deal. So what we have, every state that would like to use nuclear material today has to present many different standardized documents, and the agencies then, based on these documents, will perform inspections so that it can ensure the international community that the material that is being employed for Pacific use as foreseen in an agreement, that we don't have the production of a war material. So the agency has an inspection personnel that could make sure that will be complied with. So there we have different that is very much sedimented and ongoing with our internal installations. When we're talking about onboard reactors, what in regards to the military, we have these safeguard deals that foresee we have other applications that are obviously prohibited, for example, for any sort of bellic. So that is foreseen in the safeguard deal. So most of the times we had these deals that were made with the agency so that the agency would be able to inspect and to audit the use of this material. But in the case of civil shipping, we don't have that really, because we have these facilities that have to follow standards from that industry. But when we're talking about the naval sector, it might be built in one place but might be operated in a different place, and we have this procedure that should be in accordance with international agencies for specific cases that will be more complicated really than a fixed on board, for example, that is always placed in the same location. But when we're talking about mobile reactors, the inspection becomes a little more complicated, and maybe there are solutions that have to be implemented that will be different from regular standards, just quickly. So that's a very important subject. Jefferson, you mentioned that the nuclear agencies in Brazil, we have many norms that are being incorporated and used for SMRs. But in these norms, I don't know if you would be able to talk about the main process of licensing. What's the difference between a large modulator, a large reactor, and SMRs? So just like I mentioned before in my presentation, I had an example of a report, a preliminary safety report that we have written. So you can see that the content is basically the same. The difference is the entity and the type of information that we have there. So for example, we have chapter systems of safety. So for a smaller reactor, they will have smaller systems. We will have a description of how a certain safety function may be performed, considering physical and aspects of SMRs. For accident analysis, they will understand what are the possible accidents that might happen and the possible consequences of that accident, because it's a smaller structure. We will have a different evaluation, maybe a smaller evaluation if we're comparing it to large reactors. So, for example, if you have 5 or 6 modules in the same site, I will have to consider the influence of one event on top of the other. And again, the existence of a licensed module will help us a lot when we're talking about the evaluation process. So basically it depends on the project. And now going back to Marcio, you have mentioned before the importance of social engagement. So in the project of Wyoming, I don't know if you could elaborate a little bit more about the importance and how did that process with that interaction of the towns and state and even federal level, how did that happen? Perfect. So let me just go back a little bit before answering to your question. I thought that this conversation was incredibly productive. Thank you so much for the knowledge brought to me by my colleagues and the Brazilian Marine. So these conversations are very important when we're talking about the industry. When we're talking to these communities and the end users, really. The refinery that can use a microreactor or data center that can use a microreactor. I want to go back to a different approach. Not this conversation about industry, but the conversation about application. I mentioned how the energy sector is important in our state, and it provides a lot of prosperity and wealth. When we're talking about nuclear energy, it's basically the same approach. It's not an approach about technology, it's an approach about what the application can provide to society. And going back to the comment that the Admiral made, no one has ever built a nuclear submarine worried about the cost of the fuel that would be for example, a diesel based submarine. So basically there's no conversation on that. When we're talking about advanced reactors, I think that what a reactor can open the door to that conversation is really where it starts. So if you allow me to share a few slides with you, I have one here about innovation that does not mention technology and harmonization of the partnerships. So they are very important, but here you can see in this the innovation cycles. If you think about what happened from 2000 to 2020, we had this huge jump in innovation. So that's the benefit that we are trying to bring. So we have digital networks. So when you go to digital industry, for example, they're always trying to talk about how these transitions go to the process side. It's a completely technical conversation. So can you imagine if we have that sort of conversation with the community? That this technology will allow applications that we might not even foresee, really, in terms of telephones, for example. If we were talking about speed, and so we don't talk about that. We just give them the technology they're going to benefit from. So we're basically we have no an idea that I present here is that you can imagine the energy sector, the generation of energy is very centralized, and some of them are decentralized. So advanced reactors will create these opportunities very equally, a unique opportunity. So the conversation that we have with our communities is, what are the doors that are going to be opened when we're talking about mining, for example, reducing the emissions of CO2 in the gas and oil sector. Producing steel, for example, with that type of energy. So that's the approach. The community of Cameron sees that reactors as a new possibility for industrial development. And then this conversation about technology and the quality of products that come by it, it's completely redirected. Does that make sense to you? Does that answer your question, Carlos? Yes, it definitely enriches our perspective. I don't think we have there's not only one way to talk about this, and I think that what you said just it's very important that we shouldn't only talk in technical terms, but in more human terms. Well, I'd like to thank you all for the great contributions for this conversation. Thank you very much, and I would like to ask for the audience to help me thank our speakers. In sequence, we will have 3 videos of our sponsors of nt2e, and then we will continue with the next panel. Thank you very much for your presence.
We breathe energy. We depend on energy. We produce energy. We transform energy.
Voltaremos em 5 minutos. A próxima palestra é em 5 minutos. Obrigada.
For a greener planet. For medicine. For clean water. For safer food. For our future. Energy for life. Ross Atom.
Seja muito bem-vindo à Eletronuclear. Conheça um pouco da atividade da Central Nuclear Almirante Álvaro Alberto, instalada em Angra dos Reis, no estado do Rio de Janeiro desde o final dos anos 60, antes mesmo da construção da rodovia Rio-Santos. Nossos cuidados com a segurança contam com os métodos mais avançados que a tecnologia nuclear mundial dispõe. E isso vai muito além das sucessivas barreiras físicas existentes em nossos prédios. Temos procedimentos técnicos e administrativos rigorosos e um sistema de treinamento constante de nossos colaboradores. A produção de energia nuclear acontece sem parar, 7 dias por semana, 24 horas por dia. Isso porque ela não depende de nenhum fator climático, como chuvas ou vento, para gerar energia. Essa energia é limpa, produzida com tecnologia avançada a partir do beneficiamento do mineral urânio, uma riqueza da Terra que se transforma em luz para agregar segurança e confiabilidade à matriz elétrica do Brasil. Diferentemente de outras fontes, a geração de energia nuclear praticamente não produz gases de efeito estufa. E isso é importantíssimo para conter o avanço do aquecimento global. E tem mais. Como a nossa produção de energia é concentrada em uma área muito pequena, as usinas podem ficar próximas aos centros urbanos, onde estão os consumidores. A operação é monitorada regularmente por órgãos nacionais e internacionais que atestam a qualidade de nossa operação. Nossa central nuclear possui 2 usinas em pleno funcionamento e uma terceira em construção, além do Observatório Nuclear, que é o centro de visitação da empresa. Veja Angra 1. Esta é Angra 2, inaugurada em 2001. Esta é Angra 3, em construção. Assim que Angra 3 entrar em funcionamento, a central nuclear vai conseguir atender dezenas de milhões de pessoas. Será um grande avanço para o Brasil, que pode sofrer com o desabastecimento de energia em tempos de estiagem. A tecnologia da eletronuclear é tão segura e de ponta que pessoas do mundo todo, de todas as idades, querem ver isso de perto. Por isso, o Observatório Nuclear fica de portas abertas de domingo a domingo. Entretenimento, informação e uma vista belíssima da central nuclear promovem uma experiência qualificada sobre a energia do futuro. E no dia a dia, realização a realização, a eletronuclear está nas casas, com as pessoas. Também está na natureza, com diversos programas de preservação ambiental, como o projeto Tartaruga Viva e o Centro de Reabilitação de Animais Silvestres. E onde há uma usina nuclear, há a natureza preservada. Diversos programas monitoram a qualidade do ar, da água, bem como a fauna e flora do entorno da central nuclear. Essa é a energia que acende o futuro. Eletronuclear. Energia limpa.
Last panel, the name of the panel is the development of technological solutions for the nuclear area, opportunities and mechanisms for cooperation. We intend to show this regarding the regulation of the sector. We would like to talk about an academic activity also and how to establish the political responsibilities of the sector. So we are trying to show what is interacting with the industry. So the name of the panel is regarding this approach of considering the lectures and the debates to show our intention and what we have to offer, and also what we have been offering and the potential that we can concentrate our work. So I would like to invite Dr. Melanie Arquila. She is chemical engineer and she worked with industrial management. Sorry, the sound is not reaching the booth so that we can proceed with the translation. She has more than 20 years in the area of innovation in the public and private sectors, and she works in the productive system in Brazil. I would like to invite Dr. Cássia Ditterman. She is chemical engineer. O microfone dele está muito ruim.
Pós-graduação em Ciência e Tecnologia de Reabilitação, Minerais e Materiais CVCM. Responsável pelo Laboratório de Escanação de Energias e coordenadora do projeto. Construir repositório a rejeitos radioativos de baixo e médio nível. Convidar também a doutora Isolda Costa. A doutora Isolda Costa, engenheira química pela Unicamp, mestre em tecnologia nuclear pela Universidade de São Paulo, Instituto de Pesquisas Energéticas Nucleares, PhD em corrosão, obtido no Instituto de Ciência e Tecnologia da Universidade de Manchester, Centro de Corrosão e
Technology in Manchester. She is a researcher of EPAIN, and she acts as the chief of the lab for protector investment in the science of materials, and she's the director of research development, and she led the international program with France, Chile, and Spain, and she has also some works with Belgium and other countries. To end the composition of the panel, I would like to invite Dr. Regian Ruth Guimarães. She is chemical engineer by the Federal University of Minas Gerais, and she is a doctor in the production engineering and technological area by the University of São Paulo. She is a researcher of the Center of Nuclear Energy. She worked in the area of reactors and the heating of uranium. She was also the manager of the transfer of technology and innovation and the coordination of CDTM. Currently, she's the manager of the management of innovation, responsible for the activities of transference of technology, partnerships, research, the technological service provider, and intellectual property. And we will start this panel with a lecture from Daniela. She will talk about the creation of opportunities and about cooperation mechanisms with the industry. Good afternoon to everyone. I don't know if it's a coincidence, but we only have chemical engineers in this panel, but let's continue. I will present and focus on the opportunities and cooperation mechanisms for the nuclear sector. That is one of the activities of SENEM that I think that it may be not so well known, and that is very supported by the law of innovation. I will talk briefly about SENEM. I will not last in this subject, but I would like to talk about our ambition and our deliveries in 2022, our outcomes. So we execute research and development in the nuclear area and also the secure use of the resources. So last year we delivered all these numbers that you can see, more than 10,000 technological services, 132 items of technology development, radiopharmaceuticals, more than 20 million items provided, and other tests and radio tests, and also the capacity building of more than 200 professionals that were graduated, 429 articles published, and all the part of management, storage of radiative waste. So more or less 1 tera, right? Is this word correct? Well, briefly about SENEM. We are here in Brazil. The technical scientific areas are 7. We are present in different states, in Minas, in Iapoque, São Paulo, we have IPEM, in Rio we have IRD, and the regional centers in the northeast, and also in Pernambuco. And how is this work of SENEM in the area of PDI, of research, development, and innovation, which initials PDI in Portuguese? What we deliver to each state, the society consider the services that we offer, not only the management of the radiative waste, but we deal with it also with the emergencies in this area. We have an expertise with human resources and also the part of research, development, and innovation that I will talk and do a connection with the new framework and the opportunities and the cooperation, the mechanisms of cooperation. So we produce radiopharmaceuticals in different units, and we have the products and services that are sold, including the radiopharmaceuticals. And also in this area of the state, we work with the nuclear safety, with all the regulation and monitoring of the facilities. And so briefly I will talk about each unit. We have the CDTN in Minas Gerais states with all those competences. I think it's important to talk about the competences of each technical scientific units, because based on those competences we interact with the entrepreneurs. So I will not read, but I will leave this presentation available with the production of this event. CDTN. I like to highlight what I think that is a strong point, at least in my point of view. CDTN acts on the area of strategic minerals, so there is a sector of nanotechnology besides all the traditional nuclear part, the technology of reactors, the processing and the management of waste, the capacity building. We have master and doctorates with some specializations in radio prospection. The regional center of the Center-West in Brazil has an actuation that is more specific regarding the monitoring of the radiative waste, considering the accident in Goiânia. So there is a specific focus and deals and clarify issues with the public, with the population regarding the concerns that they may have. The Regional Center of Nuclear Science in the Northeast has an acting regarding research and development, also some service in emergencies and nuclear tools. There is also the teaching in this subject and also the monitoring and storage of waste. EA, it's in Rio de Janeiro, is the Institute of Nuclear Engineering. I will focus the reactor that is refurbished in the project from FINEP. It's a facility that supports the researches, the analysis, and the obtention of and in the teaching and the service providing, and also regarding the radio tracing in the industry of oil and gas that will be presented further in a cooperation with a small company with a technological basis. There is a startup that is in the incubator of POP and Petrobras. Also, we have a group that acts in radiopharmaco and neo radiopharmacos. Also, we have people of health, the development of instrumentation, the master in science and nuclear technology. So this is more focused today with research and development in the health, industry, and environment area. IPN in São Paulo is an institute inside the University of São Paulo, and also the program of master and doctorate is in cooperation with this university, and also we have a program of master in a professional level that is very present in the project in the RMB. Is the reactor that we have in Brazil and produces different radiopharmacos in the market of SENEM. We have 38 radiopharmacos and act also strongly in the research and development and applications and technologies of radiation, biotech, laser, some materials that are advanced in the area of nanotechnology, so different areas that are competitive, that were developed due to the nuclear sector, and then today I would say that is affecting other industries. IRD acts on the support of monitoring and the regulation in the nuclear sector, and also has the research and development in the area of radio protection, the methodology of the radiologies, and also provide services regarding technology in the labs of methodology and in dosimetry, and also acts with teaching, capacity building with radio protection, the medical physics, and also it's ready to respond to emergencies, and act also with security in the nuclear area in huge events, among other activities. We cannot state everything here. And lastly, we have LAPOC that supports this regulation area with researches with regulation, and also deal with emergencies in nuclear sector, and develop methodologies regarding radionuclides, and also acts in the part of waste storage. So talking about this, I will end with the structuring projects of SENEM. You may have had the opportunity during these days to know about RMB, that is the reactor multi-proposal in Brazil. We also have the lab of nuclear fusion, and also we have the Center of Technology and Nuclear and Environment. And to talk about the opportunities and the cooperation mechanisms, I will talk about our system of innovation management that was started in 2007, just after the innovation law that was published and that was regulated in 2005 and was reviewed. We had a revision in our standard regarding the creation of our policy of innovation in 2019-2020. The policy was in 2019 and the system of innovation management was reviewed in 2020 due to the new framework of technology and innovation that started in 2016 with new laws, and the decree also that boosted this subject and other laws in the national basis that deals with research and development, and this regulated the innovation law, and this law came in 2018. So based on this, I will talk with you about those opportunities. And just ending, our system is based with the niches that are the centers of technological innovation in each unit, considering that some of them has, like niche 7, in which I work. I'm the manager of niche 7, and that work as a center for the other units that are the regional centers and HAPOC. The other units of research, EA, CD, TN, and RD has their own center. She coordinates the CDPN center. So we are a system in a network. We act together, implementing all the actions focused on the promotion of technology transference and the management of intellectual property of SENEI. And there is a committee of innovation that is composed by the coordinators that deals with more the subjects that are more strategic and also the standards. So all the standardization of innovation is mentioned in this forum. So talking about opportunities and mechanisms, the new Brazilian legislation in science, technology, innovation, since we have an amendment 85 in the Constitution in 2015, the law 1324 that changed this decree in 2018 brought a lot of opportunities regarding the interaction with the entrepreneurs. Regarding from the side of SENEI, I highlighted these 7 opportunities and mechanisms so that we can debate here. So the law allows and stimulates to create environments to promote innovation among the companies, to share the use of the infrastructures, the use of the labs, the materials, and also the intellectual capital, and then also provide services regarding innovation, and then may have some activities of technological extension, the partnership with research and development, and the transference of licensing in technology, including the intellectual property. So considering these opportunities, I joined them in 2 by 2 because they are complementary. So the sharing of the use in the infrastructure has the objective to increase the synergy in our vision with the excellence in the entrepreneur sector. So the idea is to use the competences of our units that are accumulated in the way of intellectual capital, the research and development, and the infrastructure to move forward with the capacity of technological innovation in the company. So many companies don't have infrastructure to have the research, and they are in this technological basis to implement new technology or innovation in the market. So this is an opportunity to these companies, mainly the startups, because they have a benefit of the sharing of taking the opportunity of this sharing of infrastructure from a public ICT, because the law stimulates this sharing to focus on the activities of incubation. So a small company that has a research or students that had the doctorate or the postdoctorate, and also in SENEI, in the units, they can create a company and and take the opportunity of our facilities that we can share. So in this sense, we work. So the allowance of the use would be a design that is a little bit more complex for for a big company. But how we see this happening? A company can have the interest and look for the unit, the IPEN, CDTN, BRD, to having the interest in a certain lab to develop their researches, and then we start a process of having an authorization term to use that facility, or perhaps a bid to call companies in the sector or in the lab, considering the time that is available in a certain lab so that they can share their infrastructure with the companies. This would be another mechanism. There are also the consortiums of companies. So I would just want to say how we see this together with what innovation brings us as an opportunity. And also, again, considering this, we create those environments that are promoting innovation. So this is the idea, to have a movement from the companies inside the units, and so that they can exchange the knowledge, and also among them, and among them and SENEM. So the service provider regarding technology, they are together because we have this. The service provider is when a company asks a specific service that is not a routine, and the extension of the technology is when you have the transfers of knowledge of SENEM to the society. So you may be having this knowledge, this transfers of knowledge in a way of capacity building, training courses. This is the way that we visualize this. So the service provider is an agreement with a company to have a specific service that will improve a product or a service. And this is not an innovation. It's not to generate a new product, but it's to improve a type of specific point that a company may need, an improvement for the collective, or to improve a product, process, or service. And the technological extension, we visualize this more as a training program or a capacity building. The idea of this service providing and the extension is to organize the competences of SENEM in certain areas in the labs that may have this potential to have the service being provided as an initial pathway to move forward in a partnership in a long term with the company. So we believe that there is the initial step if they start using the services of SENEM, like a service in a short term, or participating in a training course, so they can ask SENEM to develop a good partnership. So we have some cases that are ongoing in CDPN, with a service providing in a movement in these labs, in gamma radiation, in the isometry of the radiations, and the areas of materials that are minerals, and the capacity building in the radiological and nuclear areas. And we have 2 post-graduations in Lato Sensu ongoing, under negotiation to have the classes, and we have the management of radiative waste in CDTN. Besides that, we have the service providing and in some technical issues. Regarding the partnerships, and the transferring and licensing of technology, the partnerships are the joint activities that is this different for the service providing in technological sector regarding R&D and to generate a new process, project or service. And due to this joint development, there is the matter of generating the intellectual property that should be protected. So in this specific case, those are technologies involved by SENEM together with the company. But we still have, on the other hand, our R&D that with results that are, we should protect them with the items that are developed. And on those items, there are some technologies that are really, that we call the technologies that are owners, that are the patents, the softwares. So this is what we have in SENEM as a whole. So there is a generation of know-how, some technological solutions, and the intellectual property in this mix. So we can transfer. We may have the licensing of a patent in a company or a cession of this intellectual property that will pay us, and then they will be the owner of the technology when this is developed together. And lastly, I mention here the support foundation, because we would not be able to do this without this foundation that is very important in this process. The foundations are managed by a federal law from 1994, and there is a decree that regulates all the way to work with the support foundation. SENEM has today three foundations that are authorized. That is FAC, that is the foundation that supports the scientific computing. That is one of the units of CT, the FUNDEP, that is the foundation that supports the development of the R&D of the Federal University of Minas Gerais. And the Foundation Pacto, that is a foundation from CTMSP, the Technological Center of the Navy in São Paulo. So it's there is a high level of technology in this region and the surroundings. And also we have the foundation that is from IPEM in São Paulo, and the Foundation of Support in the Development of Technological Innovation that is linked directly to IP. So the foundations are very important in this process because they give agility that we need, not only with the projects of R&D, but also with the service providing. Without them, we would not be able to have this agility for the service providing or develop something together with the companies, and at the same time to have an institution that can manage the financial resources of those projects. And considering the innovation and how this was regulated recently, this innovated also in the matter that the foundation can capture, manage, and apply its own revenues in a public ICT to develop projects of R&D and innovation that may be priority for the management of the innovation policy of ICT. So we see this as an opportunity to then to have this circle happening.
Let me just quickly present a little bit of what we have of opportunities that it's our portfolio for the case study and debate. So this is our scenario of patents and computer branch and programs. These are the radiopharmaceuticals that are already in the markets, but we have this portfolio available. And this total accumulated value of 307 is the amount of assets of intellectual property. I think this graph is a little small, but if I don't know if this slide can be available for you. So CNE has a very diverse portfolio. We have since nuclear technologies to fuel cells to technologies that are applied to cell fuels to many other industrial sectors. All the material and in the welding sector is also linked to these nanotechnologies, the processing, fine organic chemistry, macromolecular chemistry. We have a few new particles that are being mentioned. And I'm so sorry if this is an English graph, but these are the areas. And this is the nanotechnology section. So these are the areas. This was a study, an internal study that we performed, and we identified from the patents which are the ones that contain nanotechnology and what would be the applications for them in terms of green technology and environmental technology. And just lastly, this is our most recent portfolio in 2022 in those areas. So you can see here that we have a very diversified portfolio, not only in nuclear technology itself, but also in other areas that we understand that are part of the competition. And these companies, they are looking for us because of our diversity. And moving on, I have a few successful cases. I bring to you the units that are present here at this roundtable so we can debate the partnership that we have with big companies such as Codem and Vale, the sharing of laboratories and startups, institutional projects of research for the development of innovation with other partnership from the private sector that make these investments possible for these projects, of SENEM projects, technological service providing, and also the radioactive waste management. We also have a very strong partnership with Petrobras and Atom. Petrobras is a technological company that is also very much present in oil and gas sector. We have the Argonaut, the strengthening of the radiopharmaceutical laboratory of Golar, and the capacity building program for radio and nuclear areas. And there are many other partnerships with private companies and startups, and also companies like Electronuclear and Costel, Petrobras, and partnerships with also ICTs, the Butantan Institutes, and many other centers with the support of Fundep. I think that's pretty much it. These are the benefits that we are trying to bring to society so we can foster this productive chain. We're not nuclear, but we are open to these opportunities for the sector, for the nuclear sector. That is the main goal of this panel. And so we're at your disposal for more information. That's it. Thank you very much. Thank you, Daniela. It's a huge challenge to show, to talk about Canaan and the units and its attributes. So we're moving to the next, Ledola. She's going to talk about the Center for Nuclear and Environment. Good afternoon to everyone. I'm going to do my presentation standing up because I'm a very agitated person. So I'd like to thank you all for being here up till now to see us talk about this. So this panel, we're just really talking about what SENEM does, and my role is to talk about Centena. So I have here on this slide for you so we can talk about this So what is the objective, the main goal of Centena? Centena, that's the Nuclear Center for Environment and Technologies. One of them is to have the 2.0 radioactive waste management that were generated in Brazil because of nuclear energy, and also being a center where we have PEDE activities in the radioactive area, so we can focus on this area. So the main goal of Centena is the management of radioactive waste. Since the past time that we have made this evaluation, we have had a total cost of 130 million reais. And now we have 5 different places that we are analyzing to have new sites open. So we're considering Minas Gerais, São Paulo State, and Rio de Janeiro State, and we have a deadline of 5 years from now. So here we have the main generators. So we have the medical use, agriculture, the environment, the industry, and also the energy generation by nuclear centrals, and also small producers that their waste go to medium average storage that are also part of Centena. And we have our own treatment for this waste, our own storage, and every time we finish this process, we then send them to their final destination. Here we have the research reactors of Senem. We have the power plants of Angra 1, 2, and 3. We have CTMSP. We have SINA, and we also have around 5,000 radioactive installations in Brazil. So this is the scenario of radioactive waste in Brazil. This subject is not really new in the world. We have many places, many locations that have their own final deposits for radioactive waste and is spread through all continents. We have a few that are in operation, but we also have a few ones that have finished their operations, like one in Goiás and one in France, and we also have a few under construction. So why Senem is involved in the construction of Centena? Well, because Senem is legally responsible for this radioactive waste, and so we have to be responsible for the destination of this material. So the main idea is to be able to help Brazil with this type of waste. So just so you can understand, the highest amount of radioactive waste are low to medium level of radioaction. So we have this spin-off to really help with every other kind of waste so that Brazil can truly identify as a green country, because we have to show that we know how to use our resources and take good care of our wastes with safety. So the Institute will contribute to that sector once its deployment will complete the sequence of radioactive wastes cycle. And we have to comply with environmental and technological standards that are put to us internationally. And just a reminder that Latin America does not have a repository for these waste types. We also provide, we are trying to keep on moving forward with the goals for sustainability that were imposed to us. And so these applications are possible. We have to have a location for us to put our waste safely. So the nuclear techniques So the nuclear So if everyone can read here. So these nuclear techniques, for example, in the agricultural use, might help eliminating fome. It's one of the main goals of these sustainable goals, that is to end hunger in the world. And we know that if we're able to eradicate hunger, many other of these demands end up being accomplished because you end up working with better health situations. So we are present in this ODS from the UN. Nuclear medicine, it's pretty much okay because we all know of the uses and applications that we have been doing that for a while now. Even SUS uses a few of its applications, and in Brazil that's something that we're able to accomplish. The control of quality from water reservoirs by isotropical techniques, it's something that we have also been able to comply because our water depositories are very safe and accessible to. So objectives number 7, I'm not going to talk a lot about them because they have been, other panels have been talking about this clean energy, because to know that we are able to have these clean energies and still have economic growth. Now, the control for nuclear process, it's something that we have been discussing for a while now, from the beginning of the process until measurements for leveling. So that part it is already at use. So this brings to us an improvement and innovation in our processing, an action against the global climate change. We know that electricity generation with low CO2 emission helps in that ODS, and it brings other applications that at the end of the day will be able to help with other ODS. And obviously isotropical techniques in agriculture allows the soil to be used with better quality, and that will bring to all the benefits of a more democratic use of the soil. So that's all possible because all of the waste that would possibly be thrown in these applications can go to Centena, because most of them will then be destined correctly. So we have established our mission, vision, and values of Centena. As a mission, we have to promote sustainability of nuclear energy throughout its applications, with safe levels of disposal of these radioactive wastes to guarantee the nuclear energy development safely as a whole. And our vision is to be a reference center worldwide for the technological deposition and development of radioactive waste management. And then our values is sustainability, safety, transparency, quality, ethics, and respect. So what are the impacts when we're talking about Centena? For the country, we have quite interesting impacts because we're able to commit socially, economically, and environmentally. So we do not want any accidents because of radioactive waste. We already have a sort of difficulty to show and to prove our qualities. Why would we want that to happen? So with that, we have our legal commitments also, and we have a vision of a really green country that knows how to use its nuclear energy and deal with its waste. And while the project is still under construction and the organization of all the deployment of Centena for the local communities, we're able to generate jobs in both for site characterization, for construction, and then after for operational jobs, and also capacity building for these workers that will work with us in the future. So we're constantly offering courses so we can improve our operations when it is working. The improvements for local structures, for example, we have a road part that will be the responsible for Centena will end up remaining for the local population. When we're talking about environment and technology, we will have a continuous environmental management, and we will also be able to generate environmental data bank that will be available for the Brazilian population. We have PDNY and GRR that will also be available and will be used for other types of waste. In the part of economics and safety, that region will receive by law the royalties, and the sectors that will be benefited will be food service, hotel service, and transportation. We are also talking about physical and environmental safety, not only by sites, but also because legally we have to deal with that of a radium from Centena. So the project, right now we have we already have our scenario, our volumetric inventory, and we have prospection of future facilities. We already have a conceptual project that's ready, and we are right now in the end of the process of site selection, and we're just waiting for the government approval, and as soon as we finish that, we can move on to the next phase for the executive process and conditioning process and operational process. And as we have seen in other panels, licensing is in every part of the process, even for Centena. So we have financial sustainability data because we want Centena to be self-sufficient. We had a market analysis made, a projection of revenues, and Centena will be able to provide that self-sufficiency of their own finances. We had storage centers from France and Spain that work basically just like Centena, and they operate that way. And so just to exemplify here, what would be those revenues would be services of characterization, services associated to labeling, services with waste management, services of PD and Y, and services of consulting and deployment of RR deposits. We will be able to have experience in all that. And then our and so what are the results that we have until now? We have a site that has been selected and chosen. We have a business plan. We have implemented this Lato Senso course in the management of radioactive waste, and we have this first class that will end up now in May. We have risk management plan because we have an investment thesis because we have a few potential investors, and also our public communication program is ready to go. And the next steps, we have the approval of the chosen site, the characterization of that site, the deployment of public communication program, the execution of basic projects, licensing, as I have mentioned, that go through all of those phases, and commissioning for the operation. Centena and the nuclear cycle in Brazil. Here we see our P&D. So we know that our cycle goes from exploitation, benefiting, usage, transportation, and then deposition. So we already have a model for part of the research, that is the models of waste management, logistics and transportation, all of the safety analysis, capacity building for the employees, communication and preservation of information, natural barriers, because you can see that we have many natural barriers that will hold our waste. The and like it has been said before, the preservation of knowledge, because an information by itself is really nothing. It might have numbers and many papers, but what really matters and what will remain to next generation is the preservation of knowledge. And we have to remember that in our area we have a life cycle of seconds, but also a life cycle of millions of years. So what we know now is very important for future knowledge, and so it needs to be constantly updated and improved. So the preservation of knowledge is one of our priorities in Centena. And as a spin-off, we are able to collaborate the efficiency and the efficacy of raw material usage for the mineral, and we also have the norm material managing, including its use, the usage and transportation, for example, agriculture and in medicine. We have to develop this supply chain for logistics and transportation, and in deposition we have to develop and qualify providers, regional providers, to provide containers and concrete modules, develop modules for other harmful waste, and also a conditioning and storage of waste. So opportunities of partnerships we have with characterization of the site, the execution of REMA, the control of process and products, radiological and physical safety, IT safety development, because that technological part is not only IT, but all of the data that an inventory that comes with it, constructive process with, because in Brazil we have these constructive processes that are amazing, so we can account on our partners. The installation and operation of equipment, we have national, but we also have international equipment. We thought about commissioning and also a partnership with startups. And with that, I finished my presentation.
De sucesso nacionais, o Brasil está implantando o Centena, centro tecnológico e ambiental que vai trazer uma solução definitiva de rejeitos radioativos no país. Com um investimento de 130 milhões de reais, o projeto vai garantir a máxima segurança na retenção de materiais gerados em atividades como produção de energia elétrica, medicina, indústria, agricultura e meio ambiente. Mas por que isso é tão importante para o nosso futuro? Vamos explicar em 3 pontos. O primeiro é a segurança. Com capacidade de armazenar quase 500 vezes o volume de material gerado anualmente pelas usinas nucleares brasileiras, o Centena concentrará esse material em apenas um único lugar, para que possam ser monitorados com muito mais eficiência. Toda a operação terá controle radiológico e ambiental permanentes na instalação e nos arredores para conferir ainda maior segurança. Múltiplas barreiras serão utilizadas na contenção desses rejeitos. O segundo ponto é o desenvolvimento. No Centena, os pesquisadores poderão estudar soluções para o gerenciamento de rejeitos radioativos, a fim de criar novas tecnologias para o setor. O terceiro é a difusão. O Centena tem um compromisso com as gerações futuras. Para isso, além de contribuir para a formação de novos profissionais, o centro será uma base de estudos, difundindo novos conhecimentos para a sociedade brasileira e garantindo um futuro mais sustentável, desenvolvido para ser um centro de referência mundial. O Centena será um legado nacional por muitos e muitos anos. Centena, Centro Tecnológico Nuclear e Ambiental, um núcleo de segurança e sustentabilidade para o Brasil.
Com isso eu quero agradecer e nós temos uma página dentro da
thank you all, and just to say that we have a web page that contains many information about our project. We have other videos. If you're interested about it, just look it up or just come talk to me. Thank you very much. Thank you very much. We still have a little bit of time for our debate. I have a few questions to make. I'll just ask Regia to make her final considerations about these two presentations. I'd just like to say that both presentations were very clarifying, were very enriching, and I'd just like to talk a little bit about Daniela's presentation about the importance that we have of the structuring of management for innovation of SENEM, and we can enjoy the best that this law allows us to. So we have innovation policies in SENEM, and both INs that belong to SENEM are also at work. But with this normative that we have, we can use the innovation law in its whole and use all of the opportunities and benefit from all of the opportunities. And that's why we are having this panel, is how our potential partners, especially in the nuclear sector, and all of these institutions are our partners, and they're very successful with this whole predictive sector and more specifically the nuclear area. I would like to show our partners here, and then we now have a big partnership with MD with the commissioning of Caldas mining. It's a big project that is very successful technically, and it's the first experience that Brazil has with nuclear decommissioning, because we have a very high radiological waste with Caldas Novas because of the age that, and we have that opportunity with MD, and that's where we're trying to expand our partnerships. And something that's also important to mention is the help that we need with the waste management for the oil and gas industry. It's a huge problem we have, and for the companies that that have storage and use sites that could be used for other uses, so that's no environmental solution. We just have that deposit. That's so our partnership with Petrobras for that subject is very important to be mentioned. Now, let's go to Kasia, or should I continue? Okay, so I would like to talk about Kasia. We're part of the same institution. We have been working for many years now.
And I think that the issue of Centena is the budget to move forward with the institute. as he has this part to be an ICT and an institution that is scientific and technological that may have different partnerships, and with the project it is sustainable. Cássia, what do you think about this? That is, we should look for partners to be able to build Centena, or we may look for some partners afterwards. What do you think about? In fact, this is the funding of Centena. This comes from the ministry. So the Ministry of Science, Technology and Innovation is the sponsor of the project. So we, as coordinator of the technical and managerial part, the financial part should have been done. But okay, so our difficulty is first the change that is very fast. It's very frequent of the minister. So every time that we have a change of minister, we need to talk the story all over again. So this is a difficulty that we are facing. So our perspective is now be able to talk with the minister and involve him in this work. But because even with the parliamentary front, we have an annual situation. So we have an issue also regarding the resources that should be used in the same year. And as the resources, for example, for building, licensing, the previous licensing that is minimum 1 year and 2 months. So this is going forward in a fiscal year. So the idea is to work together with the ministry, so that we can work not only as a Ministry of Science Technology, but with all the stakeholders, so that we can be able to get this budget that is enough to work on. And the other matter is to work with a partner foundation, and then having the budget, we having this funding regarding the financial resources, so that we will not have the breach of any agreement from 1 year to the other one. So this is the point that we are managing now. So this is a work that we are doing, but on my point of view, this should be thought of before, because this is not a project from the ministry. As I show here, this is a project from the state that will be useful for all of us, everyone that uses the nuclear energy or the studies and application has this proposal. And the other part is the foundation. So this is our work. I would like to say also that we will have a workshop with the main stakeholders in Belo Horizonte in the coming month to take a look on this issue of investments. And we have in the platform of CTI Invest. So our project is already there. So this was already approved to receive investments, and now we need to have the investors really and the financial resources to be able to work. Isolda, your final remarks. Você quer ir embora? First of all, I would like to thank the organization of the event to open the space so that we can talk and know each other a little bit more. I think this is a possibility to show the possibilities of cooperation, and to have the collaboration. We need to know each other, and we need to trust. And we only have trust if we know each other. And this is a positive circle. So we thank, and we hope that this can happen more frequent. It's important to have more interaction, to have more cooperation, to know the opportunities. It was really a good thing to Daniela to present in 14 minutes everything that Sinem that has in terms of framework, in terms of possibilities, and regarding intellectual capital, infrastructure. And this we will need in a more detailed way with the entrepreneur ship sector. And I think the objective also for us that is here in this nuclei to see new possibilities where we can act. We are representing a capital of investment in the country, in our background. If we get here, we are chemical engineers, so we represent a capital that is very huge in terms of what the government invested. So they invested in the infrastructure of the institutions, they invested in our capacity. So we would like to provide this to the society in the way of collaboration, returning, but by participating with the business sector, we need the sector in the way of investment so that we can really provide reinforce what we have in terms of demand from the government. We have our roles, but we have skills and possibilities and a certain urgency because, as we know, we are in an accelerated reduction in the number of employees in our human resources, and this capital of investment of decades should have the knowledge transferred. So a possibility of partnerships in agreements of innovation is that we can hold for more time our human resources capital, so that we can have more time to transfer the knowledge. So I think this is very important. And in this panel, it's important that it was very well led by you, that is with the women here. So regarding the two panels, I already mentioned that it was presented in a general way. There is one more situation that is important to talk now, talking about EPEN, that is not our area. We have today in EPEN 14 projects and agreements of partnerships with the private sector, and we have 51 in a phase of work to make it concrete. But in fact, as we signed it too, and thanks for the event that accelerated the process of signature of the agreements with INB, this was fundamental so that we could have an acceleration. So now we have 16, not 14. So last 51, I should reduce 2. So we have a huge interest in the sector. We have a project with Eletronuclear that represents more than 13 million reais that started last year. We have also some projects that were done last year. In 21 with Petrobras, we had projects. I'm talking about the nuclear sector. This with INB and all others may come. We have with INB a wider interest in the treatment of waste, and 2 were signed. And so I believe that it's very important to have this happening in a way of partnerships. We can deal with this regardless the reduction of human resources, and we need this support of resource in the Center of Technological Innovation and the support in the management of the projects. This is fundamental. So it's important for you to know. I think that Daniela did an excellent work to show this in a very summarized way. And regarding the work presented by Dr. Cássia, I think that it's very important also, besides this point of the funding, the definition of the site, the place, because I have a certain interest in this definition of the place, because I want to be the partner in another project that we are conducting in the research in the whole, and we cannot move forward without knowing where it would be, because we need to know the place. So it's very important. I don't know how to do this. I will return this question to you. How are you going to define this? So it's not 5, it's 1. So from that point on, we can work together and be able, because we have an issue that is to what to do with our points that are in the intermediate storage, but what to do with this? So I think that we could be a partner in this proposal, and I know that we should wait you to have the licensing, but after that we will get a ride on this. So we had a long process to characterize and select the places regarding the norm 606, defining the regions of interest, and then have the preliminary areas. Then we came to some candidates places, and then getting there in these places. And one place, it's a public land that was from a department of the government, and we already had an agreement to have the allowance of using the land. However, due to this part of pandemic and all the circumstances and all the changes in the government that we had, now this is being asked by this department to, they are asking about the continuity of this. So in case they really, if they deny this allowance to use the land, we have 4 other places, but we need to have the places, to buy the places. So we are facing this issue right now. We are working with the authorities so that we can again visit the places, and this place that is public, to verify if it's really available to be used, so that we can continue. The greatest difficulty that I feel, and I apologize because perhaps this is the stars, but this thing of we're not going to say yes or no, this is not with me. If we say yes, we will occupy the space and we will go. So it's simple. It's a simple answer, but the indefinition is the worst case scenario, because we are facing this for 1.5 years. This indefinition is very bad, and things that we could have been moving forward and having our partnerships with all the stakeholders and the project, we are not able because we are with this on hold. They don't know, and this is the worst thing. And I'm an engineer also, so I want to resolve the problem. I don't like to say problem. I think there are issues that everyone should take a look, and let's say, okay, I don't want to participate anymore. Okay, no problem, no worries. Let's move forward. I had a meeting in Brasilia in February, and it was what I told to the minister. Let me start. Can I start? If this doesn't work, you can say bye-bye. But let us start, because I don't know if the president will want. We have a lot of if. So if we don't know if it's going to work, this is, and then they say, no one wants. But in Brazil, we really don't want if you want or not. So there is another point. Tomorrow we will have other people, and waste is the same thing in our house. If you don't care about it, this will be an issue in the future. Thank you. We don't have time. This is a subject that deserves like 3 hours for this debate, and this would be short, but it's all call the attention for a very important point, that is to be here in this space. I would like to thank Abdan for the opportunity, and we are always willing to be close to the industry. This is important mechanisms for us. We want to participate on this, to show what we do, and to say how we can work. We are short on our time, the remaining time, but so focusing on the subject of the panel, there are opportunity and cooperation mechanisms. We have the difficulty to internalize some routines of cooperation or create mechanisms in favor of this cooperation, to have the relation, mainly the researchers, they have difficulty to have the relationship with the private sector and also with the partners. So they're a little bit shy. No, you're not. No, the four of you you're not shy. So just try to show what is working, what's not working. So I would like you to comment, Casa, considering the approach of the possibility of partnerships, I would like you to comment what is working, what is not working, what are the tools that are working, what are the partners that work it, because in our idea, why this work it or not, and these mechanisms, so the people that are here can know and to be closer to us in a very nice way. I see, Fabio, that there is no partnership that will not work. There are some partnerships that are harder and others are not. And I like to say what Isolda already said, that for us to be able to have a partnership, we need to have trust. And we don't have trust in someone that we don't know. So when we start a partnership that is small, with a service providing, we have more chance to have this working. In our case, I can say that we had two partnerships that started small, one with the Mineração Taoca and the other one with ArcelorMittal, and today we have 7-8 years with the joint partnerships that started small and were increasing as the partner got the trust in CDN and saw the result of the analysis very well done, and from this point on the partnerships are growing. With Arcelor is very interesting because this is a technique that of characterization of ozone. They use a technique that is very sophisticated, where from a certain characteristic of the ore, of the composites, they can determine what is, in terms of pollution that is in that region, and Vitória Port, for example, what is due to the activities of Arcelor and what is not due to Arcelor. That is, or is an investment is required for the environmental corrections, in what it regards to Arcelor and the other companies that should resolve. So it's important to identify where Arcelor is impacting the environment and take the actions to correct it. I think the result would be great. And this partnership is really working. The other one is regarding Mineração Taboca. We started also with the analysis and process of the iron ore. We start with the process, and now we will begin with the separation of the land, because this ore has the nitrogen associated, and then we will use the land in a way that is more, you can make more profits in the company than the main business today. So I think that these two partnerships started very small and they are lasting a lot. So this is very important, I would like to highlight. And the other point is the support to the small companies. That is a strategy of CDTM to support and accelerate the increase of the startups with technological base. We have 3 startups working in CDPM, sharing our spaces and the knowledge that they develop in their projects, but always with the support and supervision of our leaders in the lab. So we have been having partnerships very important that we consider, and CDTN helping companies without, how can I say, without a financial return, but then the company also is providing services to CDPN and help us in the solutions in the waste, for example. This was our waste. It was our great partners, the first one, and we supported them in the processes of development. So the company was born in CDPN, and the 3 partners also participated in our project of graphene and dealing with the environmental issues regarding the waste. And today they are a company with a technological basis, and we are supporting and trying to support them to continue in the market, because the park of labs in CDTM, it's very large and it's very important. And the other point is that with these partnerships with a bigger company, we can keep the lab and mainly the people, because this is a huge problem also. There is the issue of retirements and without any replacement of the personnel. So the external investment, the investment that the companies consider with CDTM also can support in the maintenance of the equipment and people. So I think that it's important, it's very important. And we are short and in our time, so we would like to highlight that what we have today regarding resources in reference with this partnership, public and private, considering the resources, the creation of the project and also the partners. So the total of the projects, we have the project Cine with Shell, and they are and they had 36 million. So if we add all the projects, this of 13 millions and 600 with Eletronuclear, with the one of Petrobras, I'm not talking about the INB that we just signed it. We have the total of 83 millions for the whole period of the project. And this considering that our budget is not more than this. So this represents to us a participation that is with a lot of meaning in the entrepreneur sector. So what do we believe that it's working? We think that it will work when we really have a partnership. When the company is investing, we need the investment in human resources, the scholarships in doctorate or postdoctorate. And in fact, really, there is an investment also in the part of infrastructure. That is something that we really need to modernize, to have the maintenance of the equipment. This is very important. And also the follow-up. This follow-up in a frequent basis to show what was done, the discussion with the companies. This is very important for the success of the project by itself. And this development over the project of this trust, I think this is fundamental to have this working. We have a group in INB that is not from nuclear, is the cell of fuel and hydrogen. This group has the program with Nissan, Shell, and also with Rota 2030. So they deal with projects. It's a very small group, but very productive. And we have also today in the project in another center. This is the Center of Chemistry and Environment. It's a project that we consider with a lot of success. The purpose is to have the isotopic split of the lithium that is very important to the batteries, and this is working because they are now in the second phase, because this is being a success, and we have this profile. A good relation between the coordinator, the company. This is a trust that was developed. So there is an investment to have the equipment. We already have an evaluation. It was cheaper to have the equipment, the new equipment in independent, paying all the analysis that should be done. So I think this is the reason of the success that we have to do. And we think that is very important, this part, to keep our people that had the expertise for more time. So this is fundamental. I would like to say that IPEM is graduated. It's important, this story. The majority of the knowledge in the nuclear area to the country. Our program that you know of master and doctorate, this academic program together with University of São Paulo has more than 3,000 people graduated. So we have more than 1,000 doctors and a couple of people that has a master. So besides this program, we have a grade that is very high in our institution of scholarship. So we created a program, and now it's our program. It's EPAIN program, the Professional Master in the Technology of Radiation and Health Technology. And we have this master with 39 studies, and when they were competing to have a new program, they were the only one approved in medicine. So they aim the graduation of people that's already in the market. So there is a program of classes with a special time. So we believe that this is to contribute with the society also, graduating people that will act on the companies in the future. Thank you. Dani, your final remarks? Well, I would like to say that I'm very happy with the result of this panel. I think that we have a long way really to have this partnership with the business sector in a concrete way. I think that we have a lot of thinking today, what we have in terms of partnerships of the projects of EPAIN, CDTM, that are there, are done without or with a, we are not so proactive, and the company it's arriving because they know that the institution has the competences in the technical and scientific areas. So we are not running after the company. We should have a big team. But so this is a challenge. So I think that as part of DPD, what we have said, I think that we have this role that is more strategic to support the units. And I understand that we need to give more visibility to our institutions. Obviously, we need people to work with us, not only in the part technical, scientific, in the R&D, but also in the management part, in the innovation management, that leads to be able to deal with this huge amount of projects. But I think that our role is this, to try to organize a little bit more our competences, so that they can be more clear to the business sector, because sometimes the company doesn't know what to ask. So for those that know what to ask, as Shell, INP, they know that they need that expertise, and they run after. And then the other ones. A gente chega. We should organize ourselves with the society. This is an issue that is from the nuclear and these other areas that I don't consider that they has to do, but they are competitives. I say like this. As Isolda said regarding the fields, I have different projects, and this. So I think that we can help. And Fabio asked, what is working? I think what we can work is to have more visibility to the competences and the patents. I think I focus on the part of the intellectual property as and outside Brazil. I was in an event, joining an event this week, and a researcher presented an article from the Department of Energy in the US, and the technology was a technology already known, but he had the new software with AI and other things used with the machine learning, and he was able to have in a company interest in releasing a bit of that technology offering in the market, and having the investment that this lab did in the technology and asking the value equal from the part of the company in a financial investment or non-investment. Obviously, we cannot compare the dynamism of the US companies, but we need a kind of strategy that deals with what be the that are protected. So the idea is to move to the next step of DPD with the units, with the needs working together in the project to increase the transfers of technology. This would be the way of SENEM to be more proactive to reach these companies.
First of all, I'd like to thank Celso and people from ABDAM that gave us this space. That's very important. We're always talking in scientific forums, so scientists talking to scientists, that's it's always a little difficult. Just an example I'd like to give of an interesting partnership was once Fiat in Betim, Minas. They had a problem with SEA in environmental terms, and they asked us to make a report, produce a report about all of the waste that's generated in their facilities, and we were able to do that easily, organizing the flows and bring to it their licensing, so how they could do that correct, appropriate waste management. And then they found out that they were able to recycle and reuse some of their waste. So it's really a matter of putting our knowledge at these companies' disposal. So just like Daniela said, we have to show people what we do. Now, regarding Centena, I hope that in the next convention we could be already discussing other factors, and we will be able to get our investors so we can work more. So thank you very much, and thank you for the audience also that's still here with us. I would like to finish this panel then. I just remembered a comparison that our president had done in the beginning of the week. He compared like as an iceberg. You had results as the top of the iceberg, and obviously we have the laboratory infrastructure and capacity building programs, and it's valid because we want to be seen that way. We want people to see the tip of the iceberg as opportunities for our private partners and the industry, and also offering results to society. So thank you all very much. Thank you to Celso, to Abdan, and so we can show a little bit of what we do here. Good evening.
Antes de subir aqui e debater também.